So hello my people, welcome back to the lab. Well, today I need to show you something, and it's a guidance that I need to show you on how we do some of these things. Well, but I think I need to ditch this hat. So have you ever looked at something like this? So this is a board, and this one is from a smartphone. This one is from a hard disk that we worked on some time back. Well, have you ever wondered how people work on such small components? See how the components are? Like, if you look at this chip, you can see how small the pins are. Well, the question, I will repeat the question again. Have you ever wondered how possible it is to work on such small components? Well, turns out it's very possible and very easy. We need to get to the bench, and I'll show you how we do that, and I'll give you a guidance on how to do this. Well, but before then, there are two products that we need to use, and those two products, I have them here. So this one is what is known as a solder wick. This is a solder wick. It's just strands of copper wire that are, braided together. We are going to see how to use this. And the other product is this one. So this is solder paste. Unlike your solder wire, so this is a solder in form of a paste, and we are going to use that. Well, what better way of showing you this other than heading to the bench? Well, let's head to the bench. We do this. We are at the bench. There are a few things that you will need when doing any SMD work, and first thing that you might need is a way of securely holding your board or whatever you are working on. I have this contraption here. It's just a clip that is screwed on a huge heatsink. So this clip will hold your board very well. So the other thing that you need is this. So you need a pair of tweezers or just one, and not unless you have very tiny fingers. Of course, your fingers have to be heat proof. So this one is very good in plucking components from the board. The next thing that we are going to need is this. So this is a solder wick. Its work we are going to see in a minute. The other thing is this. This, I said, it's a solder paste. It's just solder in a paste form, and this is how it looks. It looks like this. And of course, sometimes you might need your soldering wire, or rather your solder wire. So the next thing that you need to have is your, of course, working with SMD components, you'll need a hot air station. The hot air station is this, and first we turn it on. We also turn the soldering gun, this one, on. We set my temperature, I want it to be at 350. Don't go too much, you might damage the board, as you are going to see in a few. Then the airspeed, you don't need too much airspeed, because too much airspeed will blow the components of the board. Make sure that our temperature is at 350. Now that one is okay. So I think now we are set. So now the first thing I want to show you is how to remove something like a charging port. So this port here, it's a micro USB port that we need to remove. I'll show you how we do that. I think we did this in a previous video where we worked on a phone that was not charging, but then I didn't have the solder wick with me, and also the solder paste was not present. So today we have both of them, and let's see how we use them. So of course the first thing you want to do is to hold your board like this. Make sure you have one of those board holders, or you can make one like I did here. So let me zoom in right there. The other thing, you want to remove any plastic thing from your board, or you can just shield that plastic from being heated up. So you can use something like this. I think we used that. So you can cover your plastic, maybe it's a pot you want to cover, so you can use something like this. So the next thing we can do now is to come up with our hot air, and we want to heat the entire board, or you can just heat a larger part of the board closer to where you are working on. So the reason why we do this, this one is called preheating. So you want to make sure that the regions are near the thing that you are working on the board are as close as possible to the temperature of what you are going to be working on. So this one prevents something we call board delamination, as we are going to talk about that later. So you don't want to have a very huge temperature difference. You know, the expansion of the copper layer on the board will be different in those regions. So you want to make sure that the temperature is good enough around that area, so that you don't have that massive difference when it comes to expansion. So right now we go closer to heating this pot, and it's straightforward. Just lift the the pot up like that. Very easy. Again, you don't want to have very high temperatures from your hot air station, but something like 350 degrees will do. The pot is off. We have some we have these pads here, then we have these 4 holes where the legs of the pot goes. You know, you need that firm support there for the pot. So the next thing we do, before we put in a new pot, we need to clean this. So we need to clean the pads, we need to clean these holes, and that's where this guy comes in, our solder wick. Now another thing to note, in an earlier video I said that we have 2 types of solders. We have 2 types of solder wires. We have the leaded and non-leaded solder. So from factory they use unleaded solder. It melts at a higher temperature. So we need to remove that unleaded solder, so we need to use this leaded solder. So this is a leaded solder. It melts at a much lower temperature, so we need to just add a little bit of it, and just a little bit. It will assist us in removing that factory solder. So the other thing is this. Now this is the use of this. So this solder wick is used to clean these pads and also sucking solder from these tiny holes. Now I want you to see how this works. You can also use some flax to assist the process. So this is a flax, so I will scoop a little bit there and then apply it to our board here. So we can start with cleaning our holes. Just need to place it there, and it will suck the solder like a master. So you have to keep on cutting whenever it gets saturated with the solder. Just cut, you shorten it. Let's go to the other side. It does a very good job in removing the solder. You clean these holes very well. Just like that. So we have one hole here that needs to be attended to. And you see how that thing does its job very well. So now we need to clean the pads. I want you to see how those parts clean up. So they clean up very nice. Now you need a paper towel, soak it in alcohol, then you can do the clean. You can do the cleaning. See how the pads are very, very clean. Now when it comes to installing a new pot, that's where this guy comes in. So this is the solder paste. I will just scoop a little bit, not too much, just a little bit of it, and then I will add it. I will smear some here like that. Don't add too much. Then there. So now I will come with a new pot, and the pot is this one here, very new. It's not the same pot that was here, but for learning purposes this one will do. So just slide it in there. Like that, and then I hit watch how that thing melts. Seems like the pins are not well soldered, so we just need to touch them with our soldering gun. You can still use our solder paste. Cover that area like that, so that when we come with our soldering gun, the pins will get soldered very, very well. Now we can make sure that our port is well. Just a little bit of the normal solder, like that, and that. So that port is going nowhere. There is not even a single solder bridge. So this is how cool that port is soldered. So let's go into macro and see. So this is how good of a job we have done there. See how good that port is soldered. The pins are well soldered, and we don't even have a single solder bridge there. That is the power of solder wick and solder paste. So now what about working on a chip like this? So this chip is so tiny, you can see the size compared to my finger there. It's so tiny. So let's desolder it and see how you can solder one. Make sure you hit the region surrounding the component, and then you can proceed to hitting the component. See how tiny these components are. Now you clean those pads. So these are the pads that you need to clean. You can't just put a new component there without cleaning those pads, otherwise you are going to cause a short. So we use our solder wick to clean those pads, and this guy is very effective in cleaning those pads. Watch how clean they get, right? Very, very effective. Those pads are as clean as they, see how clean they are. Let's focus. See how clean they are. Now we want to resolder this component, but for resoldering we can't use our regular. We still can, but this will just make shorts because these pads are very tiny. So we are going to make a short there. You can compare the size of those pads with the size of my soldering tip. So if I go using the soldering tip like this, chances are we are going to make a short there. So what we use, we can opt to use this, our soldering paste, our solder paste. We can opt to use our solder paste, and let's do that. So we apply a very, very small amount. We smear should have used a toothpick. So and now we can come with our component. Just make sure you align all the pins nicely there. Oops, doesn't want to come off. then you clean a little bit. Now let's check out how these pins are looking. Now let's have an inspection there, and that's how the pins are. Not even a single solder bridge there. You can see the pins are very clean. Very nice. So that is the power of solder paste. Very nice. So at least now you have learned how to use this paste, how to use this guy right here, solder wick. Very nice. So that's how you do it. And now let's talk about the concept of delamination. So I have a PCB here, and so circuit boards are made of two components. At the top here you have a layer of copper, that is the conductive part, and this is where we draw our circuit. And on the other side you have this material here. So this is a fiberglass, and it offers the structural strength that we need for our circuit board. So if you heat this copper layer too much, and there is a huge temperature difference between these two layers, so this layer of copper will expand more as compared to the fiberglass, and this layer will delaminate from the fiberglass. So we can do that in tests and see whether it's going to work. So first we heat this board. I've already raised the temperature. We heat at 1 point, and I want to show you the importance of preheating, why we need to preheat the board. And now there it goes. See that huge bump there? This layer is now delaminated from the fiberglass, as you can see from the bottom there. So you can tell a board that is delaminated by looking at the board and seeing some bubbles. So like you see some parts of the circuit are raised, like in this case. So this right here has become delaminated from the board. We can even punch a hole, and you can see the layer is coming off. So see the copper layer, it becomes delaminated from the board. Well, hope this guidance helps you if you want to try out electronics. Hope this one will be useful. Well, I think I'm done. Well, I'll see you in the next one.